To create our class-based files, we have to do a couple of different things. And the first is that we will need to make the file that will be our class, but think about what we are trying to do. So currently, right now, I have a file that when I run it, it creates a ball and the ball bounces up and down. And that's fine, but if I want to have multiple objects on screen, it's going to quickly grow unwieldy because each object will need its own set of values or parameters to go with it. And 2 objects, 3 objects, okay, it's doable. But if I have to do 500 or 1,000, that's really not going to be an enjoyable experience. So what we need to do is we need to create a file to represent that object. And we call it a class. A class is a set of instructions that serve as a template or a blueprint that the computer then can use to create multiple copies of that object. But each object will then have its own internal values. So it will have its own unique position, its own unique size, color, or any other properties that we want to assign to it. So it becomes a unique entity, but it's derived from a parent class or template. And we just then spit out copies of that object. So to do that, when we're in processing, what I could do is I could choose File New, and I could create a new file and save it into the folder. But what's more convenient is when I'm working here is I click on the little arrow and choose New Tab. When I do that, I can type in a name. In this case, I am going to animate a ball. So I will call that ball. Okay. The syntax that we are required to use when we create a class is we start out with the word class. We then specify the name of the class. And classes are always named by convention with a capital letter. So the name of the file has a capital letter. The name of my class has a capital letter. And inside the class, we will have a constructor where I will say ball, parenthesis, close parenthesis. And this constructor is where the object is going to define out its unique values. Now this ball is going to want to have properties like our other moving objects. If I go back to the previous file, we will see that the values it has are x, y, width, height, and speed y. So I'm just going to copy those, click over to the other file, paste it in. And it's possible when we are defining variables of the same type, these are all floats, I can do it all in one line where I can just say the type of variable and then separate them with commas. If you want, you can put them all on separate lines, and that's fine too. I like having them all on one line. I think it makes it easier to read. Now I have my variables for the ball initialized, and now I get to give them values. So x is going to be random, and it's going to appear somewhere between 0 and the width of my sketch. And I don't know that offhand, but I know that processing allows me to use the word width. Then I can say y is equal to random and height, 0, comma height. So what this will do is this will spit out a random number between 0 and up to, but not including, the width of my sketch, which in this case is 600. That second line will give me a value that is up to, but not including, 400. Now we don't need these lines here anymore. And I might as well grab these because we will need those. So I can cut these, delete, move to the class file, paste. Now my formatting is a little bit off. I can use Edit, Auto Format, or Command T. And that reformats everything. If I want my objects to be different sizes, so they're not all the same size, I can say random and say my minimum size, say 10. My maximum size, I will give it a maximum of 50. And height, I don't really care at the moment because I want these to be round balls, and I'll just use width twice while I'm defining my ellipse. They should also move at different speeds. So I will say I want the speed to be somewhere between -5 and 5. Now I choose minus instead of 0 to 5. -5 to 5 means some will be moving left, some will be moving right, some will move up, some will move down. Also reminds me at this point in time we will want to include a speed x because the original ball just bounced up and down. That was kind of boring. I want the balls to bounce in all directions. And I can put in a speed x is equal to random -5, 5. So all of the properties of the ball have been defined. It has location, size, and direction or speed. And we've now provided those all with values. Now if I go back to my original document, I will see that I previously put in comments three things that relate to my ball. One will relate to the main sketch of clearing its background. Update, check boundaries, and display. Those are the things that we want the ball to be able to do. We want the ball to update its position. We want the ball to check and see if it hit the boundaries of the screen. And then we want to specify our instructions of what the ball should look like. So that means I now need 3 methods. Anytime we have a function inside a class, that function, because it's part of that class object, is technically called a method. A method is a function. It's just when a function is inside a class, we call it a method. That's how the language works. Start out with void, update, and then there's void check boundaries, and then I do parentheses, curly brace, close curly brace, and then void display. So I've now stubbed out the 3 methods that belong to my ball. Now those 3 methods have content back in my original file that I'm going to move over into them. And that content was contained in my draw, which is my fill, my ellipse, my y plus equals speed y, and then my if statement that bounces when I hit the walls. So I can grab that, go over to the ball, and we'll paste it in. And then we have to break it into 3 places and put it into the correct method. Now if I paste it in under display, choose our fill color, we draw our ellipse. So I know these other 2 don't belong there, so I can cut them. Check boundaries. Well, let's see, this one is y is less than 0 or y is greater than 400. That means I'm hitting some boundaries, so I think that can stay, but y updating by speed y, oh, that's updating. That answered that question of where that goes. So can cut that, paste it in. So now my 3 methods have been populated with the information that previously was in my functions document. With my 3 methods filled out, going back into the main file, delete. Just going to get rid of this junk at the bottom. Now, inside my main file, functions to class start, we need a clear background function. And I'm going to put my background clearing line into that function. Now, clearing the background here, what this does is it just essentially floods the screen with gray. But if we put it into a function that clarifies in our code what is happening, and it also sets things up so that if, when we clear the background, we want to do more than just dump a bucket of gray paint. Perhaps we want to overlay something where we did the ghosting trails. Or we want to redraw the static background element. So it's a bunch of different things that we all draw, and that's part of clearing the background that overlays on top of everything. That would make sense to then put that into it. And by separating it out, it cleans up our draw function, so the draw function will become more clear and intentional as to what it's trying to do. So I uncommented these three, and then it says, I don't know what those are, because those are in the class, not here, so it's grumpy. So we can comment them back out. Now, if I run this, and we don't need those anymore. If I run this, absolutely nothing except a boring gray rectangle shows up on screen. Not very exciting, because we have not created an instance of our object. Our ball is now an object waiting for us to make a copy of it. It wants us to make something. So if we want to make a copy of it, what we do is we define our class, or our object. We say it will be of type ball. I'm just going to call it B. Then, after my size statement, I will say B is equal to new ball. So I've created an object, B. It's an instance of my ball class. Right here, B is equal to a new ball. Now if I go back into these three lines, we can tell B to update, B to check its boundaries, and B to display. And we will see that, sure enough, it works. Make the ball round under its display. If it just uses width for both height and width, that means they'll have the same value. So then when it runs, we'll see that it's round. That makes it prettier. Instead of using the height and width, another option, I could set the height equal to the width on the next line after setting the width. That would be another solution. Both work. You can do in some ways it's better. In some ways it would be better to leave it at width and height in the display down there, because it makes more sense to change the value up here instead of hacking it that way. Though the sample file you were provided uses ww on the ellipse definition inside the ball class. So if I do that, get the round ball, it's working. It has the speed x, it has the speed y, but it's not updating on its speed x yet. So if I want to do that, x is going to increase by speed x. So now my ball is speeding up on both an x and a y value. If I run it, we'll see that it goes and bounces. I will run into a problem that when this ball hits the side of the screen, it's gone, because I have not checked my x boundary, only my y boundary. So if I copy paste and then use x, so I'm just switching y's to x's. So if x is less than 0 or x is greater than, I believe it's 600. Now I could replace this 400 and 600 with width and height, and that would allow me to change in the main setup of my program the size of my document and my class wouldn't break. That would be a preferred practice to do it that way. Key thing to keep in mind is when we do it this way, it's really important and I must change that to an x as well, otherwise it won't work. So x, 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 y, 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 with height. But if I define my ball before I define the size, my sketch doesn't have a height or a width property, and then these statements will fail where I've referenced it. So if I'm going to use those values in my class, it's imperative that the first line in my setup is that. And then I don't say new ball up here, where I say b is equal to new ball, because then that would break it as well, because that's asking it to know something that doesn't exist yet. So the only caution I have is if you use height and width inside your class, and that refers to the sizes in your setup, that you don't ask the program to know what those are prior to giving them a value in your setup. That's the only gotcha there. Now if I run, it bounces off of all 4 walls. Ooh, how exciting. It's moving too slow. I'm going to speed it up. So now I can speed it up and get it bouncing. There's 1 ball on screen. Our next task is going to be to add in multiple balls and learn how to handle those. That will requires us to use arrays and loops. Part we're going to work with is using arrays. Arrays are a method that we can use to hold a collection of objects. So think of an array as it's a box that I can put a bunch of the same type of object into. So in the example file, I'm putting floating numbers into it. But I could have an array that I put a bunch of strings into. I could put integers into it. We can put objects into it. But the array wants to hold one type of thing. In this case, in my sample, I'm using floating point numbers. But the array is just simply a list or a box or a collection, or it's a way to hold a bunch of things in place. What's important to remember is each one of those items gets a specific assignment of where it is in that array. So the first object in the array is at position 0. The next object will be at position 1. The next object is at position 2. So in my sample file, I made an array that has 3 objects in it. When we are working with arrays, we will commonly see that we use square brackets for the array notation. That's the syntax for working with arrays. We use square brackets. So I specify when I create my array is going to be called myFloatNumbers. So I start out and say what kind of things will be in it. And then I put some square brackets telling processing that this will be an array, and then the name for my variable. Then my variable, I've said I want it to be a new, and then we once again have to specify the kind of thing that's going in it. I don't know if that's a safeguard to make sure we're clear, but it's the annoying part of the syntax. When I'm creating an array, I have to then specify what type of thing is going in it twice. once when I create the variable and once when I then populate it. And then I use square brackets and say how many objects are going in it. Arrays are fixed in length, so when I created it, in this case my array has 3 items in it. If I want my array to have 4 items, then I would change it to 4. And then I could populate that 4th value in my array by saying my float numbers. And then it's at position 3. It's the 4th element. And I'll say it's 200.56. So now my array has 4 numbers in it. So to access an element in my array, I use the square brackets and I specify its position. So if our array has 100 objects and we want the last object in the array, we would say, in our square brackets, I would say 99. If I want the first object in my array, it's 0. But the cool part about doing this is when we're storing our objects in the array, when we start actually using it to hold our, in this case, in our sample, we'll work on the ball object. We don't have to then know, we don't have to say ball 1 or ball 2 or ball 3. We're just saying, I want the ball object that is at position 0 in the array. I want the ball object that's at position 1 in the array, or 2 or 3 or 4. But we just say, I want that object that's there. I don't know its name. I don't know where it is on screen. I know nothing about it. I just know that there happens to be an object at that position in the array and I want to do something with it. That's really the power, is we no longer have to individually keep track of our objects, because we will just store them in this array, and then we can just loop through the array to say, okay, the first object in the array, let's do something with it. Second object, let's do something. Third object, let's do something. Fourth object. And we just cycle through all the objects that way. It's a slick way of working. So if I run this sketch, it will output some text down at the bottom, because what it's doing is it's printing out the values that are in that array. So we see the 1.44, 3.567, negative 99.05, 200.56. So it put them down at the bottom. And then I said, I want to see the first object in the, or I want to see the object at position 1, so 3.567. So we see that it worked. Or if I wanted to see the object at position 3. So we can see how it's spitting that information out into my console. When you are doing a small little proof of concept program and you just want to know, is my code doing something or is it giving me the values I want, it can be useful just to write a basic sketch like this. You don't have a setup, you don't have a draw, you don't have all kinds of complex things. You can just do some real basic work just to verify your code has the ability to do what you need it to do. So it's a good starting point. Now we can use this knowledge to work with our actual project. And this is where it's going to get fun. Going back to my ball project that I'm working with here. So we have the first original ball that we had in our project. I don't need that one anymore, but it doesn't hurt leaving it there, so I'll just leave it there for the moment. But if I want to have an array of balls, I will say ball, and then square brackets indicating that this will be an array variable. I'm just going to call it balls. It's easier when you have an array of objects. We commonly will refer to that array as the plural of that singular object class. That's a common convention when we're working, and it makes it easy that I see the name of that array, and I generally, just by the name of it, know what kind of object is going to be contained in that array. So now to populate that, I can say balls is equal to new ball, and then in square brackets I will say how many I want. I'll just start out with a basic 10 to begin with because that's a good starting point. So I've added 2 new lines of code to my project. My first is I've created my array variable, balls, and then I have now instantiated it by saying it's going to contain 10 objects. Now I just have to put them into it, and then I can make them do something. So to put them into it, we get to use a loop. So there's a reason we had to learn loops last week, because now we're going to use it. Start out and say for int I is equal to 0, I is less than, and this is where we could say, well, there's 10 objects in this array, so I could say 10, but what's going to be better is if I say balls dot, and it turns out arrays have properties built into them. Because the array object is part of the language, has certain methods and properties already baked into it. One of those properties is length. That is how many objects are in this array. So I'll just refer to it there by saying balls.length, and then do the I++, which means I will go up 1 time each time we loop through this. So for I equals 0, I is less than balls.length, I++. That now creates my core loop that I need. Then I can simply say balls square bracket I. So I'm going to say I want to designate that the first object in this. Now if I go back and look at my array file I was using before, that first object is at 0. The first time through my loop, I is at 0. So we say ball square bracket I square bracket is equal to a new capital B ball. So that now just populated my array. So instead of having to say ball square bracket 0 square bracket is equal to new ball, ball square bracket 1 square bracket equal to new ball, ball square bracket 2 equal to new, that would get really repetitive if I go beyond 2 or 3 objects in my array. Because if I want my 10 to become 100 or 1,000, this loop doesn't care. All I do is put an extra 0 here, and now I have 100 balls. That's it. Easy peasy. Now, what I can do is, if I want to prove that everything is indeed still working and I haven't broken any code, I could just give this a quick run, and I should just see the single ball bouncing because that's B. B is still there. We haven't got the array working yet, but we're going to get that in just a few more moments of work where we will have all 10, 100, or 1,000 balls bouncing around on the screen, which will be super fun. So to do this, we're going to repeat this for loop once more. So you could copy paste the for loop, or I'm going to retype it just to reiterate what's there. So for parenthesis int I is equal to 0. I is less than balls.length I++. Close parenthesis, curly bracket, return twice, close curly bracket, up arrow once to get into the empty space. That now guarantees that I have my closing curly bracket. By now, I think some of you are starting to find that closing curly brackets are really easy to forget, and that will wreck your code and make for unhappiness. Now, what we need to do is we need to tell our ball at position I to update. We need to tell our ball at position I to check its boundaries. And we need to tell our ball at position I to display itself. And once I've done that, I'm using a loop to go through this collection, this list of balls that I have, to show them on screen. When I hit go, we can see that they are bouncing. And 10's fun, but 100's better.